So now, children, we are going to start the revision class for laws of motion chapter. So laws of motion, this is a big chapter. So lot of questions you can expect from this chapter itself. So each and everything what I'm going to discuss in this class, please revise perfectly. Understood? So we'll start laws of motion chapter revision. We'll start with the section A revision. Now, the first question they will ask from here, explain contact and non-contact forces. Write the answer. Children, first one will talk about contact force. Contact forces. So what do you mean by contact forces? What do you mean by contact forces? These are the forces. These are the forces that act upon bodies. That act upon bodies when they are in when they are in physical contact. When they are in physical contact are known as contact forces. All the things are given in the notes, right? Regular class notes, I hope you guys got. Now, the examples for this that we'll discuss in the next question. Now, second statement we'll do. Second one is nothing but non-contact forces. Yes. What do you mean by non-contact forces? Any idea, children? Yes. The forces that are experienced by bodies. The forces that experienced by bodies. The forces that experienced by the bodies without any physical contact. Without any physical contact. Without any physical contact. So these are non-contact forces. So one question they will ask from this, either they will ask what do you mean by contact forces? What do you mean by non-contact forces? All the definitions we discussed in the class, just I introduce once again, that much only. Now, indirectly also they can ask another question related to contact and non-contact forces. Please write the question. Classify contact and non-contact forces. Classify contact and non-contact forces. So if you want that, you just make a table. Contact force. Right side you can make non-contact force. Contact force and non-contact force. Yes, right. The first one will be frictional force. Second one, normal reaction force. Third one, force tension in a string. Tension in a string. What are the example non-contact force? Gravitational force. Gravitational force. Next one, electrostatic force. And the third one, magnetic force. Frictional force, normal reaction force, and force tension in a string. That means tension in a string. This three belongs to contact forces because direct contact is there with the body. Now, in case of non-contact force, you guys are experiencing gravitational force, right? If I throw this pen up, it is coming down, but there is no direct contact. Electrostatic force also similar to that condition. Magnetic force also, all right? So they'll ask this type of questions also. Another question they can ask. Another question. Now, one important question they'll ask. 3A. Right. A ball is hanging by a string from the ceiling of the roof. Explain the forces acting on the ball and the string. The ball and the string. This is nothing but ceiling roof. You can consider one ball is nothing but hand like this. So which are the forces acting on this body? This is nothing but a ball, right? So gravitational force is acting downward means this is nothing but weight, right? Weight. Here tension will be there. Fine. So the two forces are nothing but tension. Second one is weight. Tension in upward direction. What about weight in downward direction? Understood? Upward direction. Second one is in downward direction. You can expect this type of question. Now, instead of this, I'm asking, generally, I'm asking another question. This one I'll ask A, now B part. 3B. Another question I'm asking. Please write this. A wooden block is placed on a table. Is placed on a table or on a tabletop. Name the forces acting on the block. Either they will give the diagram or they'll ask you to do. It's very easy. Now, this is nothing but a table. Right. This is nothing but a table. Now here, a wooden block is kept like this. What happens? Which are the forces acting? The first one is nothing but weight, which is equal to mg. Why it is equal to mg? Children, you guys know F is equal to ma. So here the force is nothing but due to the acceleration due to gravity. That is nothing but weight. M is the rem and A will become acceleration due to gravity. So A will be equal to G. Therefore, you can write W is equal to mg here. Now another force will act upward. What is that force? Normal reaction force. It's not tension. There is no string. There is nothing but normal reaction force. Please write that. First one will be reaction force from the table in upward direction. Second one will be weight of the block in downward direction. Weight of the block in downward direction. Another question we can ask, theoretical type question. Right. First question we will ask, the separation between two masses is reduced to half. Is reduced to half. How is the magnitude of gravitational force? Magnitude of gravitational force. Magnitude of gravitational force between them affected. Between them affected. What's the answer? You guys know that equation, right? What is that? F is directly proportional to, or F is equal to G into M1 M2 by R square. So according to this equation, what happened? The separation between two masses is reduced to half. That means R is reduced to mass. Then what happens to the gravitational force? So according to this equation, you can answer the magnitude of gravitational force. The magnitude of gravitational force is 4 times between the two masses. Between the two masses. Because gravitational force. Because the gravitational force is inversely proportional to the square of the distance of separation. The square of the distance of separation. I hope you guys know this. Already we understood this when I was taking this class, right? So during the regular class, already sir explained this. Once again, I'm giving this. All are important questions, concept type question they will ask. Okay. So the separation between two masses reduced to half. Then what happened to the gravitational force between them? It will become 4 times. Fine. Next one. Next one. Please write first. Next one important question. State the effects. State the effects of a force applied. On first one, rigid body. Second one, non-rigid body. Rigid body and non-rigid body. Okay. So first one we'll talk about rigid body. What happens when you apply force on a rigid body? Children, 10th standard, first chapter, fourth chapter, the first sentence is starting with the statement only. Rigid body and non-rigid body. So please study properly. When a rigid force is applied on a body, when a rigid force is applied on a body, it does not change. It does not change the interspacing. It does not change the interspacing. Therefore, it does not change. It does not change its dimensions. It does not change its dimension. But motion will be there. But motion will be there. So children, if a force is applied on a rigid body, what happens? There is no change in dimension. Force will be there. Because of that reason, the body will undergo motion, but there is no change in dimension. That is nothing but what happens in a rigid body. Now, when you apply force on a non-rigid body, what happens? Second one, non-rigid body. Non-rigid body, what happens? Just write. Change in dimension. Change in dimension. When a force applied on a rigid or non-rigid body, there will be change in dimension. Change in dimension. Motion also will be there. Motion will be there. So just understand what is the difference when you apply force on a rigid body and non-rigid body. Rigid body means motion will be there, but there is no change in dimension. But in case of non-rigid body, motion will be there also, but there will be change in dimension. Any doubts? Is it okay, everyone? So this much only the revision questions from section A, contact and non-contact force. From this only, they will ask questions. I hope so. Now, one more general question I'm just giving. Children, which factor the non-contact force will depends upon? Which factor the non-contact force will depends upon? It's nothing but distance. Distance. When the distance increases, the force will decrease. The contact of force will decrease. Understood? When the distance increases, the contact force will decrease. Please understand that. Okay, I'm not giving you that a question, but please understand that. So next class, sir will be doing the section B revision question. So till this, you guys should study and come. Understood?